Hi, this is Miss Logan. Today I'll be going over electric charges. As a reminder, our setup of our atom, we have our protons and neutrons in the center, and then we have electrons on the outside. Our electrons are the only particle that are free to jump from our atom outside. All of our electrons have the exact same charge, which makes it really nice to actually do our calculations. So protons also have a charge about of the same magnitude, but with an opposite sign. Since our electrons are the only ones that can jump, we're going to focus on these. So the magnitude is 1 electron equals 1.6 times 10 to the negative 19th coulomb. So this is our SI unit. This is our unit for electric charge. How can we figure out the total charge on an object? We'll take the number of electrons and multiply it by our charge of 1 electron or proton, depending on what we're doing. And remember, for this charge, we're using this number right here. So as you can tell, this is a very, very small number. So when you're putting it into your calculator, some of your answers are going to be very, very small, or they might look like regular numbers. When you get to that point, go with your answer. Don't try to go in a direction just because you think it's wrong or right. Okay, so let's go over a few examples. So our first one, find the net charge of a system consisting of 4.1 times 10 to the negative 7th electrons. So as a reminder, I have my total charge Q equals the number of electrons times the charge. So I have my number, 4.1 times 10 to the negative 7th, multiplied by my charge, which I got from my previous slide, 1.6 times 10 to the negative 19th. So when I multiply this out, I'm going to get a total charge of 6.56 times 10 to the negative 6, 26 coulomb. All right, so a piece of tape has a charge of 1.3 times 10 to the negative 17th coulombs. How many electrons are on the piece of tape? So in my equation, I am looking for the number that's right here. So I have my charge times 10 to the negative 17th equals, I'm solving for my number, times my charge, times 10 to the negative 19th. So if I divide by my charge on both sides, remember this is equal to E, I'm going to get 83 electrons. So it's important to really read your word problems and know exactly what you're looking for, because a lot of our units are going to be the same. Okay, so with electric force, we have a law that governs this. This is actually very similar to gravity laws. That's called Coulomb's law. Remember, Coulomb is also our unit that we use. So this gives us the force in newtons between two charged objects. So this equation reads, my force, which is in newtons, is equal to K, and our K is a constant. So we really haven't dealt with a lot of constants. Focus on this number. If you're getting confused by all these units, don't worry about them. The units are helping everything cancel out. So K is going to go up here. Then we have the two charges on an object. So they're either going to give you these two charges, or they're going to say 2 electrons. So then we're going to use the electron charge. Now, this is an absolute value. So if we do have negative and positive charges, then we are just going to make them all positive. That's divided by r squared, and our r is going to be in meters. Let's do a problem to see what this looks like. So we have a charge, Q1, with this given number of coulombs, which is at the origin. So I have Q1 right here. And I have a charge Q2, also on the axis. And it's there 1 meter away. Okay, so let's first find the electric force. So we're using Coulomb's law. So we have the force, which is in newtons, times K, Q1, Q2, for r squared. Now I just need to plug in my numbers. So I have 8.99 times 10 to the 9th multiplied by the two charges that were given. Now remember, they are going to be my absolute values, so I can just make them positive. It's over r squared, which is just 1. So if I multiply all these out, I'm going to get a force of 0.017 newtons. The last question, is the force attractive or repulsive? Well, these are the same exact charge, so it's going to be repulsive. So please fill out your Google form and submit that so you can get credit for watching your flipped lesson.